Welcome to my YouTube channel. I am Thalitakum Hutajulu from Udayana University Mechanical Engineering student. The purpose of this video was made to fulfill a linear algebra course assessment, also to educate about linear algebra. So, this is my reference. My reference from this book, Kuldeep Singh Linear Algebra, Step by Step. So, now we want to learn about determinants and the inverse matrix. The content from the determinants of the inverse matrix is the 1. Determinant of a matrix, 2. Determinant of other matrix, and 3. Properties of determinants, and 4. LU factorization. So 6.1 Determinant of a matrix. So determinant of a matrix 2 by 2 matrix. Determinant of a matrix A is normally denoted by that A and is a scalar, not a matrix. So determinants of the general 2 by 2 is a matrix A. So determinant A is A times D and C times B. So determinant A is A times D, A times D mean B times C. Example. Find the determinant of B. So this is 2, 0, 3, and 4. Solution. We have this is a formula. We substitute to the formula. So determinant B is the determinant 2, 0, 3, and 4 equal 2 times 4 mean 3 times 0. So this is a 0 and this is 8. So equal 8. Determinant B is 8. Application to transformation. So this is example. The determinant B, this is a matrix B. So we make to this is this is a matrix A 0, 2, 0, 0, 0, and 3. So we make a multiplication from B and A. So BA is 3 times B and A. So this is key absent, and error absent. So from this is a plot of the BA. So B multiplication from BA. This is error, key, and P. So the triangle PQR, 2 times 3 per 2 is equal 3. So determinant of matrix. So this is factorial. The transformation B is 8, and the determinant of B also is 8. Determinant of 2 by 2 matrix in this area scalar vector, the points 0, 0, 1, 0, 0, 1, and 1, 1. 1, and this is area 11. This is a object, so this is a transpose. So determinant A is 11. Transforming the above unit square P, Q, R, and S by multiplying by this matrix A give 11, right? So matrix A, this is a formula, and there's we have the, depending on the values we choose for the symbols A, B, C, and D. The shape may change, but the area is always AD min BC, hence the determinant A. So A and B is a determinant is positive, and this is a determinant is negative. The negative determinant changes the orientation of the area. If a matrix A, U times V, and the determinant of a matrix A, U times V is positive, then swapping vector give a negative determinant. That is the determinant V times U is negative. So we next to inverse of matrix. We have a example. This is a matrix B, C, and B. So solution, we make to the formula. This is a formula. We times A times B. So we substituting, and we get the E. So remember, A times KB times B equal K A times B. So where K is 1, determinant A is a scalar. So noted that matrix multiplication A times B is E. Oh, this is an inverse. Next, example 2 is a matrix A, B, and C. So determinant A is 13. So A inverse is 1 determinant A times matrix A. So this is a B. Determinant B, by substituting determinant B equal 3 into inverse formula. So we make the formula inverse. Yeah, so this is a B inverse. So we have the 1, 3. This is a B inverse. So determinant C. So we have the formula A times D and B times C. So 0, right? Since the determinant C equals 0, the matrix C does not have an inverse. Wronskian determinant. This is a Wronskian. So we have to know the fundamental trigonometry identity cos quadrat times x plus sin quadrat times x equal 1. Hence sin A and cosinus A are linear dependent solution because Worskian cos x sin x equals 0 or non-zero. Okay, determinant of order matrix 6 times 2. Minors and cofactor. We have to know the determinant of remaining matrix after deleting the row and columns of an entry is called a minor and the minor of the entry. For example, this is a matrix. This is a matrix A. So determinant A, F, H, and A is a minor of entry A. So entry B, D, F, G, and E. So this is deleting the row and column containing the entry A. So the entry A, C, Z, and E. Hence that is the determinant is the minor of entry A. So example, this is a matrix containing min 1. So deleting this is so we delete the 2, 3, 3, and min 4. So the matrix 5, 3, 4, and min 9 is a minor of min 1. So we have to know the definition of minor. So determinant from this is a min 70, 30. Okay, consider a square matrix A. This is a column, so if they have row and MEJ is determinant this. So consider a square matrix A. Let AEJ be the entry in the row and the columns of a matrix A. The cofactor of the entry is defined as we have example. So determine of cofactor of 5. Cofactor of 5 is this. We have to see that so cofactor from 5 is min 1, 3, min 4, and min 9. So determinant from cofactor 5 is 21. We have to know determinant A equal A cofactor of A plus B cofactor of B plus C cofactor of C. So determinant A right there. Determinant A equal D cofactor D plus A cofactor A plus F cofactor F. Example. So Since there is a 0 on the last column, it's easier to expand along this column. So determinant A, 2 cofactor of min 2 cofactor of min 2, 0 cofactor of 0, 1 cofactor of 1. This is a determinant A. So we make this. So min 2 cofactor from min 2 is this is min 6, 3 and min 7. Determinant cofactor from 0 is 0 is min 1, 5, 3 and min 7. So cofactor from 1 is this min 1, 5, min 6 and 6. So expanding along these columns is the min 24. So this is application in the coordinate Cartesius or this dimensional, 3-dimensional. So from this is a 3-dimensional. 3-dimensional box is made from the column of matrix A with volume is 24. This is called left hand handle orientation, and B is the right handle orientation. Cofactor matrix, where A is a cofactor of entry A, B is the cofactor of entry B, C is the cofactor is entry C. So matrix C is called the cofactor matrix, and it is used in finding this matrix of A. Note that bold C reference the cofactor matrix, and plain C is the cofactor of the entry C. Example, we have remember this. So first cofactor of first entry, cofactor from 1, cofactor from 1, this is so 9, 7, 1 and 0. So cofactor from determinant from cofactor 1 is min 7. Cofactor from min 1 is the min 24. Okay, we next find the adjoint of matrix A given in the above example 6.8. So we have this is a matrix C. So adjoint A equal C transpose equal, because C, this is a C, so this is adjoint A. Inverse of matrix. The next step. The next example. So matrix A. So this is a formula. So from formula we have to know that this is adjoint A. So adjoint A we have from determinant A from determinant. This is expanding along this row. So this is a cofactor min 2, cofactor min 1, 1 plus cofactor 0. So we have this is, so A inverse is 1. This is, so matrix multiplication A times A inverse is E. Okay, properties of determinants. This is a determinant area 1 and area K. This is a unit cube. Let A be any n by n matrix and K be a scalar, then determinant Ka equal Kn. Determinant A. Determinant properties of particular matrix. A triangular matrix is an n by n matrix where all entries to one side of the leading diagonal of 0 are 0. So this is a leading diagonal. A is example of an upper triangular matrix, and B a lower triangular matrix. So this is a upper and this is a lower. Oh no, this is a upper. So we have to know determinant of triangular matrix. Triangular or diagonal matrix is the product of the entries along the leading diagonal. Example. So determinant U is 1 times 5 times 8 times 10. So, and B and C and D. C. The determinant properties of elementary matrix. So this is A1, A2, and A3. So 1. An elementary matrix A evaluated from the identity matrix from the row by non-zero scalar K. For example, this. And 2, by adding or subtracting all of one row to another. And 3, by changing two rows, columns. This is, and this is. Application in the graphic. Example, this is a determinant A, so 1 times min 5 times 1, and this is a 0, y, 0 times 1 times 0, and this is 1 times 1 times 1. Determinant properties of another matrix. So this is a determinant B and 1. Determinant A if a multiple of one row add to another. The mean determinant A if two rows have been interchanged. And here determinant A if row have been multiplied by 10K. This is example. We have determinant A. So from determinant we have determinant with times to the times 2 to 23, 6 times 11. So we have this 1 into 23, 3, 1, 5, and 1, 3, and min 1. So we have this. So notice that we don't have the involved fraction until the end. It makes the evaluation a lot easier. So determinant of that metric. So determinant of regular metric is the product of the entries along a leading diagonal. So this is a leading diagonal. And this is row 1, row 2, row 3, and 4. So we make, if 2 rows have been interchanged, R1 is a formula, so R2 in R1, this is R1, have this matrix, so R2 is R2 mean R1, R3 mean R1, R4 mean R2, and R5 mean R3. So carrying out the row operation if this. So 3 times 2, 5. This is 3 times 2, 4. Other properties of matrix. This is the properties of matrix. With next is a square matrix A is invertible to the determinant of A does not equal 0. 6.4 LU factorization. Introduction to LU factorization. This is A, so L in U. Matrix A into LU, where L is a lower triangular matrix and U is upper triangular matrix. So this is example. This is an example. So LU is a 1, 1, 3, 2 is a A. This result means that we can factorize that matrix A into a U, where L and U are lower and upper triangular matrix. LU factorization procedure. 1. Multiplying a row by a non-zero constant. 2. Adding a multiple of a row to another. So operation 1, operation 2, operation U. L. Reference row operation 1, reference row operation 2, reference row operation 1. Example. We make to the row operation step by step. So LU is 1, 2, 3, 4, 5, 6, 3 min 3, 5 is LU equal A2. So E is positive position 4, 3 and 3. So this is example. From the example to make this is a 5, 6 and 5. This is U and L. Solving linear system. We want to solve a linear system AX equal B and assumes that we can break matrix A into LU. The linear system AX equal B becomes LU times X equal B in plus L times UX equal B. So we need to solve AX equal B. This is B, X and Y. This is and we solve LG will B and UX will Y. So from this to this or from this to this. Example. So this is an example. A equal LU, where L this is and U this is. So determinant L is 1, 2, 1 times 2 times 1 times 1 and equal 2, and determinant U is 1 times 1 times 2 times mean 10 is mean 20. So determinant A equal determinant LU equal determinant L times determinant U is mean 40. So hence determinant A is mean 40. This is a summary. So we can break a given matrix A into lower triangular matrix L and upper triangular matrix U, such that LU is visited by computer to solve linear system AX min B before the same coefficient matrix A but many different vector B because it is much less conventionally expensive. Okay, this is my explain. If I mistake, so sorry, and finally, thank you for watching.